Hello everyone, welcome to my channel. As previously in the previous episode, I have explained about sampling and little bit about sampling distribution. So this episode is going to be in a much detailed manner, and we are going to discuss in details about what is sampling distribution. So let's start today's video. So sampling distribution means sampling distribution of x bar is the probability distribution of all possible values of the sample mean. So here, as we are only and only studying sampling, we are only considering the sample mean, which is our x bar. So what we are going to do is we are taking the sampling distribution of x bar only, and we will calculate the probabilities within the sample mean only. Okay, so to understand what is sample mean, we must understand the formula, which is x bar equals to summation of x pi by n. It is similar to the formula of mean. So mean is our average. Okay, now sometimes what happens is we also call expected value of x bar as mu. Okay, so if the sample mean is unknown in our case, then we take population mean as sample mean. Alright, now let us understand what is meant by standard deviation of x bar. So we know the usual standard deviation of the population. Okay, here what we are doing is we are calculating something different, which is called as standard deviation of x bar. That is why we are denoting it as standard deviation of x bar as mentioned over here. Okay, so what it says, it can be shown that with simple random sampling, the standard deviation of x bar depends on whether the population is finite or infinite. We use the following notation like this. Okay, so in order to understand, there will be like different standard deviations of x bars for finite population and infinite population. Okay, so we will understand this finite and infinite population in the next slide, but as for now, just take into the consideration that standard deviation of x bar is this. Okay, now let us understand what is mean by finite population. Okay, so the formula to calculate finite population is this: root of population sample minus sample size, population size minus sample size, divided by population size minus 1 multiplied by sigma root n, sigma divided by root n. Okay, so why we are multiplying this root to our general notion? Okay, so this is required for finite population case but not for the infinite population case. This factor is commonly referred to as finite population correction factor. Okay, so as the word is saying, finite population, meaning that finite means limited. Okay, so when our population is limited and certain, what we do is we calculate the finite population correction factor. This thing is called as, this root thing is called as finite population correction factor. So how we will identify that, that I'll also tell in the next slide. Okay, but till now you must understand what is finite and what is infinite population. So in many practical sampling situations, we find that the population involved, although finite, is large, whereas the sample size is relatively small. In such cases, the finite population correction factor is close to 1. So meaning that when your population is finite, the size of it is going to be relatively larger than your sample sizes. Okay, so in such a case, the finite population correction factor, this whole thing will come to as close to 1. Alright, next. So in the case of infinite population, we simply use this formula, which is sigma by root n, standard deviation divided by root n. Okay, moving on. This is a terminology to remember, an important factor when we are studying sampling distribution. So what it says, we use sigma by root n as mentioned over here in the case of infinite population. So when we will use this, when the population is infinite, or the population is finite and the sample size is less than or equal to 5% of the population size, that is n upon root n is less than equals to 1. So what we will do is, whenever we will come across any case, we will first take the sample size, then we will consider the population size, now we will divide both of these factors. Okay, we'll divide sample size by population size. When the value will come less than or equals to 0.05, we will treat it as an infinite population. If n by n is greater than 0.05, it means that the population is finite. So finite population. In that case, we will use the formula n minus n upon n minus 1 into sigma by root n. Okay, when the population will be finite. Okay, so we will discuss this in more details when we will solve some of the business case problems. Then your understanding will be much clear. Now this is again one of the terminology. What is central limit theorem is the question. So in selecting simple random samples of size n from population, the sampling distribution of sample mean x bar can be approximated by a normal distribution as sample size become large. Meaning that, see, we have sample size. We will take 3 cases of sample sizes. Here we have sample size as 30, then we have 100, then we have 1000. So the central limit theorem says that these sample sizes can be approximated with the help of normal distribution. So this is our normal distribution, this curve. Okay, so as the sample size increases, the curve's shape also changes. Okay, so the curve will shrink. This dome, the dome in the middle, which is shown in this normal distribution, this will rise when sample size n increases. Okay, this is all about central limit theorem. And one more thing is that the sampling distribution of sample mean x bar. So this is going to be our x bar. So this can be approximated, means this can be calculated with the help of normal distribution curve. Anyways, moving on. So here are some of the important keywords to remember before solving business case problems. Okay, the question, when the question or the case contains this word within, we will always solve the problem by taking into consideration the normal distribution diagram. Okay, so when it says within, it gives us a specific range. Okay, then between is also one of the similar keyword. When the question will ask between or the question will say between, you will solve the problem with the help of normal distribution diagram. Then we have understood about standard error, population and sample. So standard error, there's a different keyword for it, which is called as standard deviation of point estimation. Both things the question will consist. Then we understood about population. The population is denoted by capital N and the sample sizes is denoted by small n. Okay, another thing which we understood about is finite population and infinite population. Okay, so when the sample size divided by population size comes greater than 0.05, then we will term it as finite population. When the sample size divided by population size is lesser than equals to 0.05, we will treat it as an infinite population. So we will just simply use this formula sigma by root n. Okay, but in this case we will use the formula under root of n minus n upon n minus 1 into sigma by root n. Let's understand this first problem in our case. So the question is saying that a population has a mean of 200 and a standard deviation of 50. So let's write this given information. We have population mean, okay? So we will denote this by mu. And we have standard deviation as 50. Then it is saying that a simple random sample of size 100. N is given. Okay, so sample they have said, that is why we have denoted it by n, will be taken, and the sample mean will be used to estimate the population mean. What is the expected value of x bar? Previously, just in some of the earlier slides, I told you expected value of x bar is directly equals to mu. So here we have mu as 200, so this will be our answer. Okay, now the other question B is asking us to calculate the standard deviation of x bar. So we have standard deviation as 50, but we need standard deviation of x bar, or else the different word for this is standard error. So we are calculating standard deviation of x bar. So sigma x bar is equals to sigma by root n. This is the formula to calculate the standard deviation of x bar. So we have standard deviation as 50. And then we have our sample as 100. So this will give us some answer. Moving on to the next question, which is asking us to sketch the sampling distribution of x bar. So what we will do, we'll just draw this normal distribution diagram. Okay, in the middle lies is your mu, and here lies is your standard deviation of x bar. You can write it as mu, or else you can write x bar over here. Okay, so this is the only thing which you will draw when the question will ask you. This is the only sketch which we have. Okay, so D is asking, what does the sampling distribution of x bar show? What it shows? The answer is simple, that sampling distribution of x bar shows that it can be approximated with normal distribution. Okay, this is the only thing which you will write. Next. Okay, so this another problem is saying that suppose a simple random sample of size 50 is selected from population. So we will write the given information. What we have, sample size, it is saying sample size. So sample size means small n, which is 50 in this case. Selected from a population with sigma 25. We have our standard deviation as 25. Then the question says, find the value of the standard error of the mean in each of the following cases. Use the finite population correction factor if appropriate. So the first case is direct. The population size is infinite. When the population size is infinite, what we use to calculate the standard error? We use sigma divided by root n. In this case, we have 25 by root 50. So the value comes in as 3.53. So in this first case, our standard error of the mean is equals to 3.53. Alright, next. So in the second scenario, the population size is given, so capital N as 50,000. Now the question has also given us a hint which says use population correction factor if appropriate. As I told you previously, in order to check whether our population is infinite or finite, we use this population correction factor, which is determined by dividing the sample size by population size. So in this case, we have our sample size as 50 and our population size as 50,000. So our value comes in around 0.001. Okay, then next step, what we do is we check whether it is lesser than or equals to 0.05. So in this case, it is less than equals to 0.05, which means that it is an infinite population. Okay, so the third step is to calculate the standard error. So in this case, the standard error is going to be same as the previous one. As our population is infinite, so we will use 25 divided by root 50 and our answer will be the same. Okay, so let's solve another case. See, now the population size has been given as 5,000. So let's check this with the help of population correction factor. What we will do, we will use the sample and divide it by population size. So our sample is 50 and our population size is 5,000. This comes around 0.01, which is again less than equals to 0.05. This is our population correction factor metric check, which we use in order to identify whether the population is finite or infinite. So we have passed the check. Again, the population is said to be infinite. Okay, so when it is infinite, what we do, we will calculate the standard error, and in this case the standard error will be the same. Okay, so the last question is D. Here the population size is given as 500. So let's check it with the help of population correction factor. We have sample as 50 and population size as 500. So this comes around 0.1, which is greater than 0.05. Okay, when you convert this into percentage, this is 10%, this is 5%. Okay, multiply by 100. So 10% is greater than 5%, meaning that the case is changing here. Our population is finite in this case now. Why it is finite? Because our population correction factor has increased from our estimated checked level. Okay, so now the formula for standard error will also change. What is the formula? Capital N minus small n divided by capital N minus 1 into sigma divided by root n. So we know this is 3.53 sigma by root n, but we don't know about this, so we will calculate this. 500 minus 50, 0.042 multiplied by 3.53. So the answer comes in around 0.15. Okay, moving on. So this is an interesting problem in which it says the population has a mean of 200. Population has a mean of. So our given information, we will write it down. Population mean mu as 200 and a standard deviation 50 is also given. Suppose a simple random sample of size. Simple random sample. Again the word sample comes, so we will use small n, of size 100, which has been selected. They randomly selected this sample, okay, and is used to estimate mu. Okay, so they have used this sample to estimate this mu. After using this sample, this mu 200 has came. Okay, now A, it is saying that what is the probability that the sample mean will be within plus minus 5 of the population mean. Okay, so whenever most of the times I have said this one thing over and over for the period of many videos. Probability means area, which leads us to draw normal distribution. Curve or diagram. So in this case, okay, so in this case, what we will do is we will first draw the normal distribution curve. Then only we can understand this beautifully. Okay, so here is our normal distribution diagram. Okay, and our mu lies in the middle always, so this is our mu. Now in the previous slide, just now I told you whenever the word within will come, we will use the approximation method in the normal distribution diagram. Okay, so our mu is 200, and when we add, this is our positive side, this is our negative side. So what we will do in this case, we will add this by 5 and subtract this number by 5. So 200 minus 5, 195, 200 plus 5, 205. Okay, that's it. This is what you will do always when they will say within. Now we left up with this much portion, so 195 lies over here. This is 195, this is 205. Okay, we left up with this much portion. Okay, so this is our probability, this is our area, this is, they are asking what is the probability, this is our question mark. We will calculate this much portion with the help of set score. Okay, So moving on, let's do the calculation. Now we are doing the set score calculation only for our sample. So as we are using this terminology, sampling distribution, so our z-score formula will slightly change. It will remain the same, but it will slightly change. Let me tell you how. This is our z, which is equals to x minus x bar, or sorry, x minus mu divided by sigma, but we will add sigma x bar. We will divide this whole thing with sigma x bar. Why? Because we need standard error over here. Okay, so let's calculate the standard error also. So sigma x bar is equals to sigma divided by root n. We have sigma as 50, we have sample as 100, which comes around 5. Okay, now this is the first step, this is the first step, this is the second step, and here somewhere I'll write the third step. Okay, so let's calculate the z score. Z is equals to 195 minus 200 divided by sigma x bar, which is our 5. Okay, this is for x1, this is for x2. You can denote it as like this. So here in our case, x1 is 195, this range. So for only this specific range we will calculate the z score, and similarly for x2, which is 205, we will calculate the z score. Sorry, which is 205 divided by 5. 205 minus 200 divided by 5. So after doing this calculation, we will get some z score. Let me remove this, clean this whole screen. So we will get z1 and z2 accordingly. Okay, so we calculated two different sets for x1, which is 195, and for x2, which is 205. Okay, so the z score comes around, it comes around minus 1.00 and plus 1.00. Now we learned in the chapter 6, we use z score to identify the probability, to determine the probability. How we determine it? We determine the probability with the help of z score. When we go and check the z table, which is given in your book, so we will do it similarly over here. As we can see over here, we calculated two z scores, which is -1 and +1. So our -1.00 was the z score. So the probability is estimated to be of this much area. So we are getting a probability of 0.1587. Okay, and we also calculated the other Z score, which was 1.00. So we are getting a probability as 0.8413. Okay, so we have two probabilities, 0.8413 and point. Alright, now we left with the last step, which is after calculating the p-value. This is our p-value, probability value. What we do, we subtract the z1 p of z1, sorry, p of z2 minus p of z1, meaning that we subtract this value from this value. Okay, bigger minus smaller, larger minus smaller value. So after subtracting this, we get the answer as 0.6826. Okay, what this value signifies? It means that the diagram which we drew just now, where in the middle it was mu, here we had 195 and here we had 205, in the middle we had 200. Okay, we shaded this portion only. So this much portion we wanted to calculate, and just now we did that magic. So this portion is estimated or approximated to be around 6826, or when if you want to convert this into percentage, it is 68.26%, meaning that the probability of sample mean that will be within the plus minus 5 range has a probability of 68.26%. Okay, that's it. Now let us understand the other problem, which is B. It is similar to the problem which we solved in the A. So B is giving us a range of plus minus 10, meaning that our x1 and x2, what we do is we minus this by 10 and we will add or sum it up by 10. So our mu is 200. So in this case we will have 190 as x1, and in this case we will have 210 as our x2. So this is going to be your homework, or I'll say your own objective. I have given you everything required. It is your responsibility now to solve this question, and let me know in the comments what will be the answer of both of these probabilities, or both of these Z scores. We will calculate Z1 and Z2 accordingly, and we will also calculate sigma x bar, that is standard deviation of sample mean or standard error. Moving on.